For Lab 3, the goal will be to understand how to build series and parallel circuits on breadboards and how to measure voltage and current on series and parallel circuits. After this week, we'll be able to explain why multimeter fuses blow easily when measuring current and they don't blow when measuring voltage. In this video, you'll learn how to measure voltage and current on series and parallel circuits. Okay, now I'm going to show you how to measure the voltage across resistors in a series circuit. Here I have a power supply set to 20 volts and 3 resistors, one of 2000 ohms, 1200 ohms, and 820 ohms. First, I will turn the multimeter on to voltage. Then I will connect one alligator clip to one side of the resistor and the other alligator clip to the other side of the resistor. This gives me a reading of 4.13 volts. Now I will measure another resistor by simply attaching one alligator clip to one side of the resistor and the other alligator clip to the other side of the resistor. And this gives me 6 volts. And for the last one, I will do the same process, one alligator clip to one side and the other alligator clip to the other side to get 10.26 volts. When doing this, you can switch the sides of the probes and your reading will be negative instead. This is because the multimeter only calculates the potential difference between input minus COM. So when the COM has a higher voltage than the input, then the output is negative. Now I will show how to measure the current in a series circuit. I have my power supply here turned on to 20 volts and my multimeter here. First I will set it to milliamps since I know that the current reading will be less than 500 milliamps. Then I will break the circuit where I want to measure. First I will measure the current through this 820 ohm resistor. So I'll break the circuit between the 820 ohm resistor and the next resistor. Then I will use the multimeter to bridge the connection that I broke. Now the multimeter reads 5.17 milliamps. Notice that the current flows in the same exact path as before, except now between these two resistors, the multimeter is placed. It is the exact same circuit as before, but with the multimeter placed in between. Now I will measure the current through this 820 ohm resistor. I will break the connection of the 820 ohm resistor to the circuit and then bridge that connection using the multimeter. Here I measure 5.17 milliamps again. This is because the current is the same through every resistor in a series circuit. Now I will restore the circuit. I will measure the current through the last resistor and I will do it backwards. Because I placed the input, because the current is now flowing through the circuit into the COM and then out the input and back into the circuit, then the current reading is negative. Now I will show how to measure the voltage across resistors in a parallel circuit. First, we will turn our multimeter to measure DC voltage. Then, I will attach a probe to either side of the resistor that I wish to measure. Here, I attach the multimeter to either side of this resistor and I measure 10.14 volts. When I go to the next resistor, I measure 10.17 volts. Across the next resistor, I measure 10.16 volts. The voltage across every resistor is the same in a parallel circuit. This is because one side of all the resistors forms an equipotential surface, and the other side of all the resistors forms another equipotential surface. This is because they are connected all underneath the breadboard. Because of that, the potential difference between one side of one resistor and the other side of that resistor is the same for all resistors, because the one side of all the resistors is an equipotential surface and the other side of all the resistors is another equipotential surface. Now I will show how to measure the current through resistors in a parallel circuit. First, we'll turn our multimeter to measure current. And I know that the current will be less than 500 milliamps, so I use the milliamps and have it plugged into the input. First, I wish to measure the current through this bottom resistor. What I will do is break the circuit connected to the bottom resistor. Now all the current flows through only these two resistors. To reconnect the bottom resistor to the rest of the circuit, I will use the multimeter to bridge the connection. Now I can read 12.73 milliamps of current running through this bottom resistor. Notice that I bridged the connection of where the resistor used to be attached. Now I will reconnect the resistor and measure the next one. To measure the current through this 2 kilo ohm resistor, I will break the circuit. Then I will use the multimeter to reconnect the circuit where I broke it. Here, the multimeter reads 5.12 milliamps. Notice that all the current that travels through this resistor comes from the multimeter. The current travels through here into this leg of the resistor, underneath through the breadboard, then up into here, and then through this end of the multimeter, through the other end of the multimeter, and into this resistor.